Hello, welcome you all for another lesson. The last two lessons we were introduced to airplane in general, parts of the airplane, and in another lesson we went through the flight controls. So then I thought it is important to cover the systems which the airplane incorporates. The airplane looks very simple structure from outside, but I can assure you it's a very complex structures from inside, and there are a hell of a lot of systems which are in place inside the plane, which I shall be introducing you all to these systems. It's not a study on systems in depth, so I'm just going to introduce you to the cursory look at each system for your understanding. It's very complex subject, so it is well beyond the purview of the scope of this course, so-called. Okay, before I proceed further, this entire subject, entire topic, it will be split in two lessons because it's vast, and so I want to keep it within about 15-20 minutes of the time. The first system which I want to introduce you is the air conditioning and pressurization system. Air conditioning system, I don't have to explain too much. Passengers are traveling, they need to be comfortable. You need to be keeping the cabin in a very comfortable temperature around 24-25 degrees centigrade. So we will just go ahead and see as to how this whole thing is achieved. To start with, there is a power plant of the plane which provides the thrust, of course, for the plane to fly. In addition, it provides for several other services. One of the services and one of the systems which it services is the air conditioning and the pressurization system. What happens is the air is compressed to a very, very high levels and for other reasons to produce thrust, etc., which we shall see when we see the power plant. At this moment, it's enough to understand that it produces very high level of compressed air, which is utilized for several systems, including the air conditioning system. This highly compressed air is then collected in a kind of a reservoir called air conditioning packs. Then let us understand that when the air is compressed, it gets heated up fairly to a very high degree. And then this heated up air is tapped. Only a small portion, very, very small portion is tapped from the compressor of the engine, and it is routed through to the packs, and thereafter it is cooled and then distributed all over the aircraft through different ducts. So that is in short the air conditioning system. I have shown it in a little bit more elaborate in this picture. As you can see, there's from one section there is hot air is being collected, and there is a system which cools this hot air to very, very cold temperatures inside the aircraft. The details of which we shall not see. It's enough to understand that there is a system which cools the air, and these two are further mixed in appropriate positions to provide the comfortable air. The control to regulate the temperature is all held in the cockpit, and most of the times it is automatic. So there are sensors all over the planes to sense the incoming temperature, and accordingly it keeps trimming the requirement of hot air and cold air mixing to adjust the temperature. That's about air conditioning system. Okay, next is the pressurization system. In fact, the air conditioning and pressurization systems almost go together. That's why it has been clubbed. Uh, the same air which the compressed air which has been routed after cooling and mixing, after it has been routed to the cabin. Now there are pressure regulators to control its leak outside this enclosed cabin. Now, aircraft fly at very high altitudes from 30 to 40,000 feet, where the atmosphere is very, very rare. So, there isn't enough oxygen for a normal passenger to breathe. So, things could be very critical. Just to give you an idea, at about 27,000 feet, if a human being were subject to a condition just outside, he can barely remain conscious for about 5 to 8 minutes, and thereafter he will lose his consciousness. Therefore, there is a need to pressurize the cabin. So what it does is this highly pressurized air is sent inside the cabin, and as the aircraft keeps climbing, the leak is so calibrated, therefore the pressure inside the cabin keeps building up. So it almost builds up to 8 times the differential. That means outside to inside it's 8 times. And as per the regulations, any passenger plane carrying passengers is to maintain the cabin altitude at about 8,000 feet. Therefore, the systems provide, even if the aircraft is flying at 37,000 feet, the cabin altitude will always be maintained at 8,000 feet or lesser. So, this 8,000 feet is very comfortable for the passengers, and absolutely there are no adverse effects. So that's about pressurization system. So in the same subject, let us understand that the aircraft shell or the aircraft body is subject to cyclical pressures. Whenever it flies, it is subject to pressure from inside, and when it gets depressurized and there are no pressures, so every time it flies, it is subject to some very high, the aircraft body is subject to very high pressure, which affects the maintenance schedules, which we shall see in a much later lesson. The next associated system which I want to cover is the ice and rain protection system. In the past, there have been several accidents which have been caused due to icing of aircraft, and we have become wiser by the day, and now we have sophisticated systems to handle this icing, anti-icing and rain requirements. I just put a picture for you all to understand how much icing that can gather over airframe, and this is quite detrimental for the plane to fly because it alters the smooth external structure of the plane. So there is a need for us to build sophisticated anti-icing systems, which I shall briefly cover. Thought it's a little bit interesting, so I thought I'll cover it. In the older generation aircraft, we had this something called de-icing boots. These are all rubber inflatable boots which are held under suction, and when the icing forms over the wing structure, these are high pressure air is pumped in in boot sections, which inflates and breaks the ice. So that was the system which was being. Okay, how the anti-icing system is constructed? Like the air conditioning system, from the same tapping, hot compressed air is tapped from the compressor stage. Now a portion of it is routed through a different valve and a different outlet, and this hot air is ducted and it's sent through all over the leading edges of different control surfaces in the plane. And when this hot air is blown, then it gets de-iced fairly efficiently. So that's how the modern systems work, and it is rooted. There are sophisticated timer units to route this hot air in at different timings depending on the requirement. And important to cover this, in almost all airports which is prone to heavy snowfall and aircraft icing, we have something called airframe de-icing before pre-takeoff. You will appreciate that it's very critical with the aircraft to take off with icing formed over the airframe, because it alters the airflow characteristics and it can be detrimental. And we also know that several accidents have taken place because of that. So we use something called a de-icing fluid mixed in hot water, which is sprayed all over the plane, and the aircraft surface is completely de-iced before it takes off. These provisions exist in all the airports which is prone to icing. There are different types of de-icing fluids, and there are time limits by the time you de-ice the aircraft and by the time you take off. This, of course, the operational staff and the pilots would be familiar with. Needless to say, it's a very important activity, and we need to pay great attention to this particular, especially when you are flying into airports which are prone to heavy snowfall and aircraft icing. Rain protection. Aircraft have to land even when it is raining, and the pilots need to look outside at some point in time. Most of the aircraft, as I've shown in the picture, incorporate a windshield wiper like you have in your cars. So the pilot, there is a switch in the cockpit, so he would operate the wiper to get a clear visibility when flying in rain and landing in rain. Some aircraft, some systems incorporate a de-icing anti-rain fluid, which is sprayed over the windshield and which keeps water from sticking to the windshield. So once again, it provides a very clear vision to the pilot. Clear, not very clear, but manageable to execute a safe landing. You may hear about the pneumatic system. So all systems, the whole thing is consolidated, and it constitutes the pneumatic system. All systems using air as a basic fluid constitute this system, and the ones which we discussed earlier, and some more systems. There are some advantages in using air as the basic raw material for such systems. It is low weight in considerations. There is absolutely no weight. Air is available practically, and you can just compress it and use it for several systems. And of course, there are no very few fire risks. But there are some disadvantages. Even with highly compressed air, sometimes it doesn't meet the requirement and it is spongy in nature. And some heavy duty services may not be serviced by the pneumatic system. So these are the disadvantages. system, that is the electrical system. So let's go through it. The basic electric supply is achieved by two or three batteries which will provide DC power supply to the aircraft. That is, when the aircraft is not powered at all and it has to be powered up, this is the first source of power that will be powering the aircraft. And of course, it's not going to power the entire aircraft, and it's going to provide power source to very limited services, from which several other services can be initiated. So there are two types of batteries that are used in aircraft systems, that is nickel cadmium and the lead acid batteries. And there are some advantages, disadvantages to both, and that's beyond the purview. It's enough for us to understand these produce about 24 volts to 28 volt DC. And let's understand that in air, if everything else fail, that means your generators and other power sources fail, this is your lifeline to provide power supply till you execute a safe landing. Let's go on further. Now the engines are operating and rotating at very high RPMs, and there is something called the accessory gearbox which is attached to the engine, to which several services are driven. One of them is the engine driven generator or alternator. I have shown it in the picture so that you all can get an idea, and I have also shown a picture of a aircraft generator, so you will get a reasonable idea how generators are constructed in airplanes. But what I want you to understand, in most modern planes, they produce this 115 volt, 400 cycles alternating current, which is the major power requirement of the plane. So that's, of course, there are some planes which may produce DC as well, but most modern planes, I'm sure, are producing 115 volts, 400 cycles, alternating current. Different types of power supplies. So a single power supply may not satisfy the solution. Therefore, there are several electrical devices which I will briefly introduce them. There are transformers which are used to change the AC voltage level. There are rectifiers which are used to convert AC to high amperage and low voltage, etc. There are some TRUs, combination of transformers and rectifier units, which are used as the main unit to convert alternate output to DC, and there are some inverters which convert 28 volt DC to 115 volt, particularly for instruments, especially in case of emergencies. So there are series of them. In fact, there are some equipment which have their integral power unit, power batteries, which means even if all the power supply were to be removed, those would continue to be serviced. That's what we need to understand. Power unit, it's a very small engine. It's a regular engine, but smaller in size, which is again works on the same principles of the main engine, but it doesn't produce thrust. Its main objective is to supply air on ground and drive a small generator which will provide the power supply to the aircraft, especially on ground. And of course, it can be started in air in case of a failure or in case of a total failure in air. So that's the auxiliary power unit. It is frequently used on ground to power up the aircraft on ground and to carry out, meet the air conditioning requirements on ground. Next is a fairly simple system, that is the fuel system, and most of us know the system. The fuel requirement of the plane for the route and its flying is stored in the wings. So you may have seen aircraft getting refueled through the wings, and all the fuel is stored in the wings for to meet the requirements of the flight. So that's a very simple system. There's that to keep it within the scope of this lesson. Here I just to put some pictures. Uh, one picture shows the construction of the wing inside, how the fuel tanks are constructed, and I put another picture of a pump. These are all booster pumps which pressurize the fuel uh, from the tank and then send under pressure to the engine. So this, I thought it's a little bit interesting, so I thought I put these pictures. That's how it happens. The fuel from the wings is collected in a central tank, normally called the collector tank or a central tank. Thereafter, it is pumped under pressure to both the engines. And I just want to give additional input that there is an interconnect duct between these two, one wing to another engine, so that even if there is an imbalance which happens in the flight between the right and the left wing fuel tank, if which could be determined in flying the plane in terms of rolling moments, so it is possible to equalize the fuel levels in both the wings. And this from the central collector tank, and it needs to be sent, the fuel needs to be sent under pressure to the engines. Next is the fire extinguishing system. I don't have to amplify the importance of fire extinguisher system, because fire hazards are the most critical hazard for any plane and in any flying situation. Just to give you a brief explanation, there is a heat and fire sensitive wire which is routed all along the fire prone areas of the engine, and which detects at any time if there is a heat phenomenal heat rise or fire, and which gives an indication to the pilot in the cockpit. That's the picture which I have shown. Once the fire is detected, there are a series of actions which the pilot will perform. That is to shut down the engine and bring it to a reasonable rotating level. And then he will operate the fire extinguishing bottles to douse the fire. Depending on the aircraft, there are several fire extinguishing agents which are used, which are contained in almost a spherical structure of containers, and they are operated automatically by a switch from the cockpit. I've just shown some pictures for your understanding, and I want you to understand that it is possible that the fire extinguishing bottles which are used for one engine, it is possible for it to be used in the other engine as well. That means any fire extinguishing bottle in the plane can be used on any engine. So that's about the engine firefighting system, and there are handheld fire extinguishers kept at different places in the plane to fight any fire that may arise otherwise in the cabin or in any other place. Next time when you fly, you may be able to spot these fire extinguishers. These all undergo periodic and regular checks and for its operability. The end of this lesson, and there are some more systems to be covered which I will cover in the next lesson. As usual, I hope you found this lesson interesting, and please feel free to offer your comments in the mail ID which is given below. Thank you all for watching this lesson.